Here is your starter. I'll give you a few minutes to see if you know how to do these. So if you could hit pause on the video and give them about 5 minutes. All right, so when we do this one, 8 to the 2/3, a fractional exponent. The numerator is the power. The denominator is the root. So this would be root 3 of 8 squared. And you will always solve your root part first. So the cube root of 8 is 2. 2 squared then, still my square, is 4. Next one, power to power you multiply. So that is 2 to the 3/2 times 4. And that simplifies to 2 to the 6th, which is 64. On my next one, anytime you have a negative power, it reciprocals its position. So right now your base is 4 in the numerator. It is going to go to the denominator and take on the positive power. So that means 1 over square root 4, which is 1 over 2. When my bases are the same, I just add the powers. So my base is 3 raised to the 3/2 plus 5/2. That is 3 to the 8/2, which is 3 to the 4th, which is 81. So yes, you are expected to know those basic powers through the 4th, 5th, and 6th power. If when my bases are the same, I multiply, I add the powers. When I divide, I should do the opposite, which is subtract the powers. So my base is 5 to the 5/4 minus 3/4. That's 5 to the 2/4, which is 5 to the 1/2, which means square root 5. So on the next slide, you're going to see all of these rules in general terms with the problems we just solved. We said when we have a base to a power over root, it means to take the root of the base raised to the power and always solve the root part first, then raise it to the power. When we have a base raised to a power means you multiply the powers. When our base is raised to a negative power, it means to reciprocal the base and raise it to the positive power. When I am multiplying two of the same bases, I add the powers. When I am dividing the same bases, I subtract the powers. We are going to spend a little time working on a few more situations with these roots and powers so that you can get more used to them. First of all, it says write in radical form and then evaluate. So remember, the fraction is power over root. So my base is 16 with my root. My root is 2, my power is 5. We always evaluate the root first. Square root of 16 is 4, and I still have this 5th power. 4 to the 5th is 1024. So the next one, 64 to the negative 2/3. Again, it is power over root, but it is a negative, so that means reciprocal this base. That would be 1 over 64, and then I raise it to the positive power. So it is the square root. 1 over the root, base 64, power 2, root 3. We always do the root part first. The cube root of 64 is 4. I still have to square, is 16. And I just did the same thing most of you will do. I can't forget that it is 1 over 4 squared, 1 over 16. Now, to evaluate, you need it in radical form, but we also want you to get used to going back to the other form. So for evaluating purposes, we could evaluate right here. Do the radical first. Square root of 49. 7, and I still have to cube it. 7 cubed is 343. So that is exactly how I want to see evaluation. Rewrite, it would be base 49 to the power is 3 over root. When there is no root there, it is understood as half. Let's do the next one. 4th root of 16 to the negative 3. We would evaluate first. 4th root of 16 is 2 to the negative 3 power. That means reciprocal your base and raise to the positive power. That is 1/8. Rewrite. Base was 16. Power was negative 3 over root was 4. Make sure when you write your exponents as fractions, you actually have them raised up and they're a little bit smaller. If I see something like this, it is very confusing to understand. 16 and 3/4 negative? I don't know what you mean, so do not write it this way. Let's take one at a time here. The cube root of 32 over the cube root of 4. When they have the same root, you can write it as one big root. I have 32 in the numerator over 4 in the denominator. And 32 and 4 reduce to 1 and 8. So it becomes the cube root of 8, which is 2. And I want to see all that work. Skip no steps. So if I can take it split and make it one big cube root, when it's all in one big root, I can split it. So 4th root of 7 over 4th root of 8. 4th root of 7 does not simplify. 4th root of 8. Let's rewrite 8 as a smaller base. 4 times 2, 2 times 2. I have 3 2's. So it's the same as the 4th root of 2 cubed. To rationalize the denominator, we would need one more 2 down here to pull it out. So I must multiply by a 4th root of 2 over a 4th root of 2. Neither comes out, so it becomes the 4th root of 14 over, now I have 4 2's underneath, so 1 would come out. Always go to your smallest base. And do not assume you're going to multiply by just one more of them. Because if this were the 4th root of 7 over the 4th root of 4, that would be the same as the 4th root of 7 over the 4th root of 2 squared. To take out a 2, I need 4 of them down here. So now I would need to multiply by 2 more 2's. What I do to the denominator, I must do to the numerator. So on top, There aren't enough 2's to pull out. There aren't enough 7's, so I just multiply that together. 2 squared is 4, times 7 is 28. Fourth root 28 over 1, 2, 3, 4, 2, so 1 will come out. So see what I mean? About not always just assuming you multiply by one of those extra roots. It depends how many you had and how many you need to pull out. All right. Fourth root of 12. Well, 12 factors into 4 times 3, which is 2 times 2 times 3. Any of that going to come out? No. So I have my fourth root of 12. D to the fourth. Any D is going to come out. One of them should. E to the ninth. This would be the same as taking e to the 9 over 4. 4 goes into 9 2 times. So 2 e's come out, and that would still leave 1 in, because 2 would make that 8, and I'd have one more. In other words, e to the 8/4 times e to the 1/4. F to the 8th, 2 f's come out. And when you have variables underneath there, any odd-powered variable will be absolute valued to guarantee it is a positive number. Negative 81 to the 3/4. To evaluate this, you have to rewrite. Notice the negative is in front. So it is negative 81 is my base, power 3, the fourth root, which gives me the fourth root of 81 is 3. So I have a negative of 3 cubed is a negative 27. If they meant for it to be a negative 81, they would have put the negative in the parentheses. Since it is not in the parentheses, it means the negative is in front of the 81. It means this. Power to power, we should multiply. So 36 to the 3/4 times 2. 4 and 2 reduce. So I have 36 to the 3/2. Make my radical. Base 36. Power 3 over root 2. Evaluate root part first. 6 cubed, 216. All right. I have two things happening here. Multiplication and then raised to a power. So if we do this multiplication part first, I would add my powers. So first, I would have 2 to the negative 3/2 plus 1/2. Then I'll raise it to a negative 3. That is 2, negative 3/2 plus 1/2, negative 2/2. That's 2 to the negative 1, still raised to the negative 3. Power to power, I multiply. So it becomes 2 to the positive 3, which is 8. 2 cubed is 8. Four ninths to the negative 3/2. Negative power says reciprocal your base, and then raise it all to the positive power. Now before, the reason this works is because my denominator was 1. But this time I have a different denominator, so I must raise the whole thing to the power. So this means root 9 power 3 over root 2. And that power also goes to the denominator, so square root 4 cubed. We do our roots first. Square root of 9 is 3 cubed, is 27. Over square root of 4 is 2 cubed, is 8. 27/8. Write with a positive exponent. So they want us to go back to exponential. Well, this is y, power is 1. So I have y to the 1/3 times, here I have y to the 1/2. But that is also under the cube root, so that would also be 1/3 power. So this is y to the 1/3 times y, power to power you multiply. 1 times 1 is 1, 2 times 3 is 6. In order to multiply with the same base, I add the exponents. To add them, I need the same denominator. 3 times 2 is 6, 1 times 2 is 2, so it becomes y to the 3/6, which is y to the 1/2. And it's said to write it as an exponent, not a radical. Now let's do the same with this one. First, just take this part. Base is x, power is 1, root is 2, times x, power is 2 over root 3, times base x, power is 3 over root 4. When I have the same base, I add my powers. This time, I need like denominator of 12. So 6/12. 3 times 4 is 12, so 8/12. 4 times 3, 3 times 3 is 9/12. So 6 and 8 is 14, and 9 is 23/12. All right, a few more, and then we'll actually try some solving. The directions are to simplify. Cube root of 3 over 3. Both your bases are 3. And I'm supposed to write it with an exponent, not a radical. So this is 3 to the power 1 over 3 divided by 3 to the 1. When my bases are the same and I divide, I subtract the powers. 1/3 minus 1. 3 to the negative 2/3. It said write with an exponent. Let's go back and make sure that it's with a positive exponent. So right now I don't have the positive exponent, so to make it positive, it would be 1 over 3 to the positive 2/3. Because it said positive exponent in the directions. The square root of the cube root of 5. So again, let's just rewrite this inner part first. My base is 5, raised to the power 1 over 3. All of that is square rooted. Square root is the power 1/2. Power to power, I multiply. 5 to the 1/6. And I believe it said positive exponent. And last but certainly not least, we do our radical first. Cube root 8 would be 2. Cube root of a to the negative 3. That would be a to the negative 3 divide 3. A to the negative 1. just like I took this power divided by root, power over root, I'm going to do the same with my b's. My power is 3/4. Fraction bar is already divided by root 3. What happens to your 3's? They reduce out, so I have b to the 1/4. And I still have to square all that. So 2 squared is 4. A to the negative 1 squared is a to the negative 2. And b to the 1/4 squared is b to the 2/4. Now we can simplify. 4 positive exponents. So the a has to move down to be a positive 2 exponent. And the b can simplify to 1/2. All right. Let's take a look at the power function. The power function would be f of x equals ax to the b. It's where the variable is raised to the power. Where before, when we had the exponential function, the base was raised to the variable. So here we have y equals x to the 3.2, and that is this graph in blue. And we have y equals x to the 0.4. We have this graph in red. It says make a conjecture about the exponent of a power function. What is the difference between these exponents? They're both positive, but this exponent is bigger than 1, and this exponent is smaller than 1. When it is bigger than 1, it's going to be a J-curve that takes off quickly. When the exponent is smaller than 1, it's going to be a flattened out J-curve. Then we have our rational function, which would be x to the 1 over n power, which means the nth root of x to the 1. The ones that we will be graphing are x to the 1/2 power. Again, that would be like 0.5. So it would be similar to this red one. X to the 1/3, that would be 0.3 repeating. Again, will flatten out. And x to the cube root of x squared, which is x to the 2/3. Again, like the red one, flattening out. 0.6 repeating. These are our parent functions that we're going to be using. So make sure you have graph paper, and let's look at the first one. The square root of x, which would be x to the 1/2 power. So when I make my xy table, and my parent function is square root x, can I square root 0? It would be 0. Can you square root 1? It would be 1. Can you square root 2? No. Can you square root 3? No. Can you square root 4? Yes, it's 2. Can you square root negative 1? No. That's imaginary. It's not real. So I have parent function 0, 0, 1, 1, 4, 2, and my flattened out whip through it. My domain, I start at 0 and I go greater. X is greater than 0. My range is also greater than 0. Y is greater than 0. And this is what I'll want to see every time you do a square root function. So now, y equals square root x is in blue. And let's see how we got the red one. X minus h plus k. Do I still have that same parent function idea occurring? So what is my shift? Right 1, up 2 from my origin of 0, 0. Then I had 1, 1, 4, 2. Let's take 0, 0 and shift right 1, up 2. Does that give me my beginning? And from this new origin, then I can plot 1, 1, 4, 2, and do my Nike. When I'm looking at the red function, my domain began at 1 and everything to the right. So x is greater than or equal to 1. And everything above 2 for my range. Y is greater than or equal to 2. Do you see the connection? Domain to the shift. Range to the vertical shift. You try this one. The square root of x plus 3 minus 2. My shift or transformation, left 3, down 2. For my parent function, 0, 0, 1, 1, 4, 2. From 0, 0, left 3, down 2. Do my new origin, 0, 0, 1, 1, 4, 2. This time, my domain, the first x used is negative 3, and everything to the right of it, greater than or equal to. The first y used, negative 2, and everything above it. Okay, let's look at cube root. So my parent function is right here. X, y equals cube root x, which is x to the 1/3. Can you cube root a negative? Yes. I could go further and I could say negative 8's cube root is negative 2, and positive 8 is positive 2. If I wanted to add those points in there, I could. So if I plot negative 1, negative 1, 0, 0, 1, 1, and that's what I like to do, 8, 2, and you can see that it makes the Egyptian S. Again, it's going to work the same way. X minus h plus k. So this should go right 2, down 2. So if I take my origin and go right 2, down 2, is that my new parent? And my 1, 1, negative 1, 1. And 8's going to be way out here, so let's go negative 8, 2, 3, 4, 5, 6, 7, 8, negative 2. And you see your parent function. This time, all x's are used and all y's are used. It's just that y's are used more gradually. You try this one. From my parent function, y equals cube root x. Cube root, I can do negatives. If you want, negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and 8, 2. What's my shift? Right 1, up 3. From 0, 0. Right 1, up 3. Draw in your new origin. 1, 1, negative 1, negative 1. Again, 8's going to run off, so let's go this way. 1, 2, 3, 4, 5, 6, 7, 8, negative 2. And we have our square root, or excuse me, cube root. So the domain, I used all reals. And the range, which is my y's, I also used all reals. Okay, let's look at 2/3, or cube root of x squared. My parent function is just that. Y equals cube root of x squared. When I square 0, I get 0. Cube rooted is 0. Square negative 1, I get positive 1. Cube rooted is positive 1. Square root 1, or square 1 is 1. Cube rooted is 1. If I would square 2, I'd have 4 cube rooted. Does that work? 3 squared would be 9 square rooted, or excuse me, cube rooted. Doesn't work. 4 squared is 16. Cube root of 16 is 4. So I could also have 4 squared 16. Oh no, not cube root. Looks like we have to go all the way to 8. 8 squared is 64. Cube rooted is 4. So we could do 8, 4 if we wanted, or negative 8, 4. But notice, when I plot those points, 0, 0, 1, 1, 8, 4, negative 1, 1, negative 8, 4, I get the seagull. So, does this match the parent function? X minus h plus k. And how will I move my origin? Right 2, up 1. So again, my origin was at 0, 0. Right 2, up 1. Your new, and my parent function, 0, 0, negative 1, 1, 1, 1, 8, 4, negative 8, 4, 1, 1, negative 1. Again, 8's going to go way off, so let's go negative 8. 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. So I'm going to be my domain, x is all reals. Again, every x value is used. My y's are above 1, so greater than or equal to 1. All right, now let's actually do some algebra, some symbolic solving. We want our variable to the power left for last. So, divide by 3. X to the 4/3 equals 81. I need this to be x to the 1. So if I raise this to the reciprocal power, would I get 1? So what I do to the left, I must do to the right. 81 to the 3/4, which means root 81, power 3, root 4. Evaluate the root first. 4th root of 81 is plus or minus 3 cubed. Remember when you put square roots on, you had to put plus or minus? The same will be 4th roots, 6th roots, 8th roots. And you put that on there. So we have to do both. So 3 cubed is 27. Negative 3 cubed is negative 27. So I get plus or minus 27. All right. This time my variable is under 2 radicals. So let's move this one to the other side. square root of 4x plus 28 equals 3 square root of 2x. The opposite of square rooting is to square. So square both sides. Square root squared is 4x plus 28. 3 squared is 9.